All right, Physical Science 20. I want to talk about molarity. Okay, it's part of our chemistry unit. What is molarity? Well, when an amount of substance, and we've been talking about moles, and the root for this word, of course, is moles. When an amount of substance is dissolved in a solution, usually a water solution, the concentration of that substance is usually referred to as the molarity. So if we have a substance, and let's say in our example here we have iced tea. Many of you like iced tea. I like iced tea. And I like really strong iced tea. Some people in my family like light, really dilute iced tea. So the difference there in concentration would be sort of the molarity, or the different strength of the iced tea. So in chemistry, when we have a solution, let's say we have a hydrogen chloride solution, which is HCl, which is a very strong acid, right? When we have an HCl, hydrochloric acid solution, there are different concentrations of that solution that you'll see on the bottle. And a really strong concentration of this acid, a really concentrated acid, would be something like 12 molar. And what that literally means is that there are 12 moles of the substance in 1 liter of solution. So in order to find molarity, you first of all need to find the moles of the substance that you have dissolved in the water. And then you simply divide it by the total solution in liters. Now, I say total solution because if you have a large amount of substance and you put it in exactly 1 liter of water, the volume of that solution, if you put in some granular or some solid compound, the total volume is going to go up a little bit, right? So again, it's important that this total solution is all of the water and the compound itself together forming the total amount. So in 1 liter of total solution, not just 1 liter of water. Okay? So here we go. If we have 0.7 moles of, let's say, iced tea mix dissolved in, and here's the key, enough water to make 1 liter of solution. So it's not exactly 1 liter of water. It's going to be just a little bit under, but the total is going to be 1 liter. Then we would say that we have a 0.7 molar solution of iced tea. So the descriptor here is molar. That means we're talking about molarity. The symbol is M, capital M, for molar. Now, don't get it confused with MOL. That's moles, right? 0.7 moles is different than 0.7 molar. 0.7 moles is just an amount. 0.7 molar would be the description for the concentration. So you could have 1.4 moles in 2 liters of water. You see, 1.4 moles in 2 liters of water equals 0.7 molar solution. You see that? So it's the amount of moles, whatever it is, divided by the amount of liters, whatever it is. Another example would be down here. Let's say we have 7.34 moles of NaCl. And we have that in, let's say, 250 milliliters of solution. Well, that's a little bit different because we have moles, yes, check, but we don't have liters, we have milliliters. So what we need to do is we need to convert 250 milliliters to liters. And what is that? 0.250 liters. Now we've got moles and liters, and so what we simply do is we divide those numbers. So 7.34 moles divided by 0.25 liters gives us an actual molarity of 29.36. Now think about this. I have 7.34 moles in a quarter of a liter. If I have 7 moles in 1/4 of a liter, I would have 7 times 4 moles in 1 liter, right? So that's where you get the 29 from. So this is a small volume, much less than a liter, so the moles per liter are going to be greater. Okay, so 29.36 molar NaCl. Okay, that's molarity. Now, a couple notes here. In your textbook and in other places, you may see this. So, for example, 0.250 liters, that was 250 milliliters. Well, in your textbook, you might see that as 250 centimeters cubed. A cubic centimeter, I don't know if you knew this or not, but a cubic centimeter, so that is a cube that is 1 centimeter by 1 centimeter by 1 centimeter. If that was completely full of liquid in that exact shape, that would exactly be 1 milliliter. Did you know that? Yep, it's true. And if we had 10 centimeters by 10 centimeters, let's say it's 10 centimeters by 10 centimeters by 10 centimeters, that's exactly 1 liter. And so that's what you also might see in your textbook here. Liters would be in decimeters cubed. So this would be 0.250 decimeters cubed. That's liters. I know it's confusing, but just so you know, that's an important note. You may see this in your textbook, okay? All right. So moving on, let's take a look at this example, and I do have everything worked out here so that you can take a look at this at your own pace. But the question is this: what is the molarity of 250 mils of solution containing 9.46 grams of CSBR? Okay, so what you want to notice is that we have an amount of solution, 250 mils, which we're going to have to convert to what? Yep, liters, and we did that right here. 250 mils is actually 0.250 liters, like we just did in our other example. The other thing we're given is a mass, right, of CSBR. Now, from molarity, can I do grams divided by milliliters? No. Grams divided by liters? No. It has to be moles divided by liters. Has to be. Right here. Molarity is moles divided by liters. So that means we have to convert this to moles of CSBR, cesium bromide. We have to convert this to liters of solution. No problem. This is 0.250. This one here is going to take a little work, and this is what it looks like. So cesium bromide. Now what you do to find the grams per mole is you take the molar mass of cesium, and again that's from your periodic table, and that is 132.9054 cesium, and bromine 79.904, right from the periodic table. Notice it's a 1-to-1 ratio, so there's just one of these and one of those. You add them up straight and you get 212.8094. That's the mass of exactly one mole of cesium bromide. Well, I don't have that much, do I? I only have this much. So in order to find how many moles this is, I simply take a fraction of what 1 mole would be. So 9 grams out of 212 grams gives me exactly this many moles right here of CSBR. So we find moles, we convert to liters, and everybody's getting pretty happy here. And we look down here. So our molarity then is calculated by using this number, moles divided by liters of solution, and here we get 0.1778 molar. And the reason why I have this alternate solution here for you to consider, this would be with proper significant figures. You remember those? Okay, so we have 2 sig figs here, 3 sig figs here. So your answer should have 2 sig figs if we're talking about proper sig figs. Now, my goal is not to pin you on the sig figs. My goal really is to make sure that you know how to calculate molarity. So that's what I'll be focusing on. Okay? So if you have any questions, you can ask now. If you don't have any questions, then here are your notes again for molarity. And you can start to work on your questions from the text.